maybe this is kind of apt to go last. So in the bad old days of 2000s and noughties, we suffered through XML hell, limited control over our environments, and vendor lock-in. So, you know, the bad days, they weren't so great. And what I'm hoping to show you that today things have not really changed much further with serverless technologies. And I'm giving this talk because so after drinking the Kool-Aid at AWS reInvent last year and having that bubble burst, it's something that I wish someone had told me. So in the words of Public Enemy, they put it so well, don't believe the hype. So I'm going to start with a case study of real-time aggregates, just to set some context and a bit of a warning. I'm not really going to focus on the details of real-time aggregates. It's just a pure high-level implementation, and it's looking at the serverless experience only. So if you want to talk about the details afterwards, I'm more than happy to do that. So let's get started. So Uswitch is where I work. It's a microservice organization. And I don't mean the architectural pattern by that. I mean we're composed of highly autonomous product teams, and we're built around a specific problem. So we own our problems, we own our strategy, we own our infrastructure, we own production, and the developers have the generalist DevOps skills to do this. So you build it, you own it. And this means we have very little external dependencies. And we also have loads of AWS experience. We've been in AWS 100%, approaching 4 years. We use microservices and Docker. So why is all this important? So like microservices, serverless technology is distributed by nature. And I feel that your organization, your team structure, help deal with this, Conway's law. With any major paradigm shift, like serverless or agile, it's can your organization adapt to it? By the way, PS, Uswitch is hiring. Come and talk to me if you want. So this case study involves upgrading a legacy service that needed a bit of a modern refresh. In essence, we wanted to build a better speed test. It could measure speeds across different device types and provide useful stats in the given area where you live and allow long-term trend geographical analysis around the UK. We've got small scaling problems and nothing too scary. So this is the entry point of the app. We collect some metadata, most importantly the postcode and the provider you're with. We then do the speed test to get your download speed and your upload speed. And then these are the stats that I was talking about. And these are the real-time aggregates that I was talking about in the title of the slide. So each incremental speed test that arrives, they get added into the stats in real time. So these requirements, they're not really untypical and they're not really that groundbreaking. So I just wanted to put that in context. It's like there's probably a lot of people with problems like this. I would like to go quickly over what the implementations look like. Again, not in any real deep detail, but just to show the growth in complexity and the distribution. So what do I mean by all-in here? So we're using entirely serverless technologies. And it's AWS as well, so AWS serverless technologies. And this is what we actually did. So given the relative straightforward nature of the requirements and it being a rewrite, we thought it was a good candidate to actually check out the new serverless paradigm. So this is a legacy solution, very typical traditional monolith, two-tier approach, and we ship the data to a data warehouse. So it's simplistic, but it's a great starting point. And a lot of people bang on that monoliths are bad, but they're great for just starting out for simplicity. So evolving that to say what microservices might look like, we'll split that into functional concerns. One's dealing with the speed tests and the other one with the stats. And we can scale either of those independently. But you can see the complexity is growing from the monolith, which we accept because of some of the advantages it might bring. So let's begin the all-in serverless approach. We started with putting a single-page app on an S3 bucket. So this is a great pattern. It's simple and reliable if it suits your needs. The speed test service, it validates and stores the speed tests. The patterns here is using the API gateway to route requests through to a Lambda function. The API gateway handles the HTTP request and response codes and the headers. The Lambda, a bit of business logic, it validates, enriches, transforms it, and then puts it onto Kinesis, which we use for plumbing for event sourcing. Then we store the data long-term in an S3 bucket, which also serves as a static API if we want to retrieve those speed tests individually. The data warehousing, that's taken care of with Firehose into Redshift via an S3 bucket, where we do the long-term analysis. The annoyance here is the Kinesis Firehose can't actually be used for anything else. So you end up with two Kinesis streams, which is a little bit annoying. The stats service. So this really retrieves the stats we short with the postcode. The new speed tests, as they arrive, are indexed straight into the Elasticsearch service with the Lambda. Really, that's how we get the real-time aggregates. Nothing too amazing there, and sorry if I was a little bit cheeky talking about real-time aggregates. And again, the same patterns before, API gateway, forwarding requests to Lambda, and that Lambda then makes makes the Elasticsearch query. So at this point, it's looking a little bit like an architect's dream, right? And then, let's not forget all the AWS security, SSL certificates, IAM role policies, bucket policies, security groups for VPC access. Now, I know what you're thinking now. Right? No one says that, except maybe product evangelists, perhaps, I don't know. So, what went well? It just works. Once we ironed all the bugs out, of course. So after 10 months and 650,000 speed tests, we've had no major outages and we've had no manual intervention necessary. Although this can be said of some of our other non-serverless systems as well. So is that something to celebrate? I don't know. So the app, and more importantly, so the app seamlessly scaled. We didn't have to think about it. That problem just wasn't a concern for us. Peak loads, not massive, 130 per minute. But you know what? We didn't have to care. It just worked. And that's pretty cool, especially if you have large traffic spikes like we do when you get national news coverage. So the costs look very promising. So that is, yes, that's $1 a month for the Lambda and API gateways, which is orders of magnitude cheaper than EC2, ELB, and Docker. That's a big win. Or is it? So if there's one thing I've learnt at USwitch is that the true effectiveness comes from optimizing the flow of work, not a single unit cost. So this isn't painting the whole picture. We've got salaries, we've got data storage, we've got database costs, and all these majority of these costs are a constant regardless of the implementations you use. So the unit cost savings are a nice side effect, but I wouldn't optimize for them up front. Lines of code, so a few interesting things here. There's more styling code than the rest of the code combined, so making things look good is really difficult. There's very little back-end code, 215 lines. The lambdas there are pretty small. And you know, if you believe in infrastructure as code, you've got to write some tooling, and most of those were kind of like Bash scripts and Python scripts. So where did all that back-end code go? Which is something I'll come to, but let's have a look at one of the lambdas. Right, so don't bother reading this slide. The Python isn't important. What's important is it's 18 lines. And that's pretty quick to grok. And what this does is just save the speed test to an S3 bucket. And that's like a lot of your lambdas start looking like that. That's great. That's a big win. So what didn't go so well? It took 4 devs 13 weeks for us to do a 3-page web app. And that's slow for us. So why was that? So with so many moving parts, the feedback cycle was slow. So getting end-to-end systems together was difficult. There was a steep learning curve. which always comes with new technologies, which is usually offset by documentation and support networks. I have to say that the AWS enterprise support is expensive, and it rarely led to an outcome for us, positive outcome. And the new tech meant little community knowledge, such as blog posts, Stack Overflow, patterns, and use cases. And I would say this learning curve was despite our extensive knowledge already of many of the AWS services. And it was back in October 2015. So, I mean, it's good to see that things are improving. So where did all that back-end code go? So 280 lines of Swagger configuration for a start. And if you look closely, you can see loops, Boolean logic, creating JSON inside YAML. And that's mental. So YAML's not a programming language. And you can see that Tommy Hall on Twitter for some more examples of rants on YAML being used ineffectively. Beyond YAML, there are other nice surprises here, like your schema is now bleeding into your configuration as well as your code, and that's a big thing. So when it comes to refactoring and modifying your data. And don't get me started on the cloud formation and IAM policy documents. In short, get used to defining your apps in AWS-specific config. Nothing kills productivity like resolving the same problems over and over again. So automating and provisioning your serverless infrastructure doesn't go away with serverless. How you deploy changes, how does that fit into your continuous integration delivery process? How do you set up multiple environments for dev and staging production? And are shared environments okay for you? So at USwitch, shared environments are fine because, like I said, the people I work with are just around me. So we're not going to trample stuff. How do you handle errors? How do you get a single view of logs? Have you got other logging systems in place as well as CloudWatch logs? What do you monitor? And what does end-to-end integration testing look like? And we've heard lots of talks here this weekend on these topics, but my point is that they're probably different from what you're doing now. And they might not fit your organization as it is right now. So expect some work you didn't plan for. So AWS is highly addictive. The free tiers, they hook you in. They're great for hooking you in. And the portable services like EC2, Redis, and MySQL and Postgres are excellent to migrate into if you haven't been in the cloud before. And these are gateway drugs to specialized services like API Gateway, Lambda and Kinesis, and DynamoDB, which really hook you in. Now, some vendor lock-in is inevitable. And historically, we've dealt with this, like strategies like ORMs, database layers, facades, but it's tended to be isolated in one layer for like database, for instance. So the AWS SDK is the new vendor lock-in point. It invades everything, from your code, your tooling, your CI, and I guarantee you isolation strategies are like an afterthought. So FYI, we've been Google Cloud curious for a while, and going cold turkey on AWS is a frightening prospect for us. So what lessons can I share? Start small. Develop your maturity in your practices, such as like dealing with deploys and security environments. Some usage patterns for increasing maturity and complexity is things like just hosting single-page apps in S3 buckets or static APIs, using Lambda as cron, Kinesis for plumbing between Docker containers, Kinesis plus Lambda for event sourcing. They're all great starting points. Automate everything. The web console, the AWS web console, actually any web console is your enemy. It's good to spike and begin familiar with how that technology works, but it's not reproducible, it's time-consuming, and it's prone to error. So get your tooling in place early. And at a basic level, just wrap the AWS CLI with Bash. There's no shame in that. And have your CI push that code and the config changes out like you would normally do. You can also use tools like Terraform to manage your AWS services. Check out our Terraform wrapper on our GitHub account, USwitch GitHub account called Terrifying. It's true. So remember, you don't own your environment. Okay, and that probably seems weird, doesn't it, where it's serverless. So you can create environments, with API gateway stages and Lambda aliases. Though be content with these environments shared between developers. And you will need permission to own your infrastructure and get that quick feedback and end-to-end integration testing and making policy changes. Does your organization trust you with production environments to do that? So remember, you don't own the functionality. So when you run into something that isn't there, you need to implement a workaround. We've had promises from our AWS account managers that fixes were coming soon, and then took a year to arrive. If you need bleeding edge, like the latest Node, Python, and Java, or even native extensions, then serverless might not be for you. So I read the other day that most car mechanics these days can't service modern-day car engines. I have to take my Toyota to a specialized Toyota service center, with warranties voided. So this is great for the car industry's after-sales market. And maybe it's great for my car's reliability. But not so great for my freedom of choice or the local mechanic. So I think there's parallels there with serverless. And the point there I'm trying to make is, which actor are you in that analogy? Are you the driver, are you the mechanic? Or are you like the car manufacturing industry? So what's true of all distributed apps is especially true for serverless. Schema changes are painful. Gone are the days of simply, database migrations and starting up Rails. You don't know immediately where things are going to break downstream. So serverless doesn't mean you can be clueless about schema changes across your deployable artifacts and your code and your configuration. So we've avoided that. So we've used things like monorepos, and that's basically helped us refactor across those different code sets. We've got a policy of avoiding breaking changes, so additive changes only. And we also automate our migrations. And finally, we also validate the shape of our data, and that's at key entry and exit points. And you can use stuff like closure spec or maybe JSON schema for that. Cool. Okay. So the future might indeed be serverless, but today we suffer through YAML hell and JSON hell. It no longer runs on my machine. And that sinking feeling that we'll never move off our cloud vendor if we wanted. That's it. Thanks for listening.